Good evening. How are you doing? So last class we discussed simple harmonic motion. We talked about the definition of simple harmonic motion, where I said it is a periodic motion of a body or particle along a straight line such that the acceleration of the body is directly towards a fixed point or the center of the motion, and it is also proportional to the displacement from that point. And I told you to take note of the acceleration. The direction of the acceleration is what? Towards the fixed point. It is towards the fixed point, which is what? The center of the motion. And I also told you to take note of the relationship between the displacement and what? And the acceleration. You understand? That the acceleration is towards the center of the motion, and also it is proportional to the displacement from the point. Then we later discussed the simple pendulum, what's this thing called? The simple pendulum rather, where I told you that it is actually one of the things we can actually use to describe the simple harmonic motion. And we discussed some terminologies in simple harmonic motion, where we talked about the amplitude, which is the maximum displacement. We talked about the period, which is the total time taken by a vibrating body to make a complete revolution for what, or let me say to make a complete revolution or a cycle about a reference point. We also made mention of the frequency, where I said the frequency is the number of complete revolution per second made by a vibrating body. And we also talked about, I introduced some formulas you need to know, where I talked about F equals to n over t, where I said this t is not the period, that this t is just what? The number of this t is actually the what is it called? The unit time. You understand? It is just like a given time, it is not actually the period. The period is actually denoted by capital letter T. And I made mention of the relationship between the frequency and the period, where I said F is equals to 1 over T and T equals to 1 over F. So I said they are reciprocal of each other. If we know the T, we can actually find the frequency, and if we know the frequency, we can actually find the T. And also we also talked about the speed and acceleration in SHM, where I said it is actually quite different from the speed and acceleration you've been introduced to in motion. That one is linear velocity, linear speed, linear velocity. But here we're going to be talking about angular velocity. And I made mention of some formula, where I made mention of omega. Omega is actually the angular velocity. You can recall that it is equal to theta over t. You understand? We talks about that, where I said theta is the what? Angle turned through the body, because we're actually talking about what's it called? The angular velocity, and this t is time taken, which is not the period. And we also talked about a very important formula in simple harmonic motion, which is V equals to omega r or omega a. So this equation actually shows the relationship between the linear velocity and the angular velocity. So and I remember last class I gave you a particular question on that, and I said, what is the relationship? This is actually the relationship. Then we did some classwork, then I gave you an assignment, and you actually did well in the assignment. So today I'm going to introduce you to another formula in simple harmonic motion, which is actually one of the most important formulas you actually need to understand. And the formula is V equals to omega square root a square minus x square. So V equals to omega a square minus x square. So the V here is actually the linear velocity. We know that. This is the angular velocity. The a here is the amplitude, you understand, and the x is actually the is also a distance also, but it's also like in meters also, but you're going to understand it better when we start solving the question.